Alright everyone, welcome to day 14 of Advent to Code. Here's hoping today's goes as well as yesterday, but hopefully it can go a little faster. I would appreciate not having to wait, do like 40 minutes of just writing code because Java's a little verbose. But at any rate, day 14, let's do this. The distress signal leads you to a giant waterfall. Actually, hang on, the signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you notice a little path that leads behind the waterfall. Correction, the distress signal leads you behind the giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumbling for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you quickly become trapped. Fortunately, you're familiar with analyzing the path of falling material that will come in handy here. You scan a two-dimensional vertical slice of the cave above you, your puzzle input, and discover that it is mostly air with structures made of rock. Your scan traces the path of each solid rock structure and imports the XY coordinates that form the shape of the path, where X represents the distance to the right and Y represents the distance down. Each path appears as a signal line of text in your scan. After the first point of each path indicates the end of a straight horizontal or vertical line to be drawn from the previous point. For example, okay, this scan means that there are two paths of the rock. The first path consists of two straight lines, and the second path consists of three straight lines. Specifically, the first path consists of a line of rock from there through there. Okay. The sand is pouring in the cave from point 500, drawing as air as that. Source of the sand as it becomes. Okay. Sand is poured one unit at a time. The next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill one tile of air as you scan. The unit of sand always falls down one step if possible. If the tile immediately below is blocked or by sand, the unit of sand attempts to instead move diagonally one step to the left or the right. If that tile is blocked, it tends to move diagonally one step down and to the right. To the left first and then to the right. Sand keeps moving as long as it's possible to do so, at each step trying to move down, then down left, then down right. If all three possibilities are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is counted created from the source. Okay. Down, down left, down right, yep, so on and so forth, fills up. Okay. Once the 24 units of sand shown above come to rest, all further sand flows out of the bottom. Ah. Cool. Gotcha. Using a scan, simulate the following sand. How many units of sand come to rest before sand starts flowing into the abyss below? Okay, that's a fun input. What is this input again? Did I copy? I did copy. Wow, okay, that's just a lot of text. Casually 20,000 characters. Okay. Great. So what is this? So this input is just drawing. So it's going from 498 to 498.6 and then 496.6. Okay. Okay. So sand starts at 500. So we need to build a grid. Well, honestly, we don't need to build a grid. We can just build a list of points. That might be our better bet. Although this is a lot. This is a big list if it is. Maybe not too bad. I think our best bet is to build a list of just a list of all the points that we can be stored at. So basically kind of a grid, but not filling in the grid, if you get what I mean. So we're going to have a list of point 2. Is it worth making this a map? You know what? Let's make this a map, because this is going to become a point and then an integer. And what this is going to be is it's going to be our grid. Let's call it a map, actually. Let's call it map. New hash map. And so what we're going to do here is we're going to go through our inputs. So for string s in inputs, what we're going to do is we're going to have to separate them on this. So string parts is going to be equal to s.split on this. So let's give us our parts, and basically this parts means now we have our instructions for what points to add. So for string part of parts is what's the best way to do this? So it's actually column row. It's backwards. Okay. Actually string chords is gonna be equal to part dot split on a comma. And integer % chords 0 is a column, row is chords 1. So given this, what we need to do is, well, we need the 2. So we need to go where we're going from and to. So actually this is better off as int I equals 0, or I is 1 actually, while I is less than parts dot length I plus plus. So this is actually going to be start. Parts I minus 1. So actually it's probably better to do this. Don't do start. So we can do start chords. Start chords, end chords. That's just I. Always add the start. Always add the end. We're gonna get some duplicates, but actually it's a map. It doesn't matter if we have duplicates. And then copy this, but this is now end instead of start. End and end. Okay, so we have our start and end coordinates here. So the goal is to just go, or is determined first if the start column does not equal the end column. They can't move diagonally, so we only have to check one or the other. So that makes things a little bit easier. And then what we can do is we can just do a for int j equals 0 while j is less than, actually we can just go from start to end. J is less than or equal to end column j plus plus. And so now we can do point p is equal to new point and go from row. Doesn't matter which one we pick. We can do start row and then do j. And let's just make this easy. Just do map dot put our new point, and we'll make a rock be 1. 0 is air, 1 can be a rock, and 2 can be a sand. Sure. Okay, otherwise, same thing, but instead of columns, we can do rows. And this is going to be start column, and that's backwards. There we go. Alright, so now we've correctly initialized our map and have assigned it out. So now we need to start spawning in. Actually, before we start spawning in sand, let's grab the lowest row. Because by having the lowest row, we can now determine when safely sand is falling into the void. So it's actually going to be integer dot max 5. Oh wait, JK. No, it's highest row, because highest is lowest because they go from 0 to higher as they go down. Okay. And just add a check here. If the end row is greater than highest row, if start row is greater than highest row, start row, there we go. Because it's going between, we don't care about the between bits, we need to know the start or end. Okay, now we can safely start simulating sand. I don't know if I want to make this a method or not. Point sand point equals new point. It's gonna start at 500 0 is what they said. 0 500 row column instead of column rows. They have it. Okay, so sand starts there, and what's going to start doing is actually Boolean falling into abyss, sure, while not falling into abyss, we will spawn sand. Okay, so now we have sand spawning. Starting here, and so what we're going to do is Boolean resting is false. So while the sand is not resting, what's the logic is sand is one new time, comes to rest, always falls down if possible. So the first step is if it's going to be point below is going to equal new point, and it's going to be sand point dot row minus +1 sand point dot column. If below, or if map dot contains key below does not contain, that means it can move below. So what we do is we just go ahead and do sand point equals below. That's easy enough, right? That's moving down. And we'll just actually hit, well, I can continue. That'll make the life easier. So what I can do is I can just copy this, paste this below, and now this is going to be below left. I could initialize all three to the top, but that's not really all that fun. Well, I just don't want to do it that way. I don't like how that looks. So, left is negative column, or is lower on column. What's going on here? Oh, why do I have a comma there? Or semicolon. Okay. Below left, if it contains below left, or does not contain below left, set there, continue. Okay, and this is below right. Below right, +1. And if you get to then, if none of these move, now we just can do is we can set resting, whoops, resting equals true. And that's it. It's always false. I don't know how that's always false. Actually, we need to do one more thing, is if below right dot row is, well, actually, no, we do this first. If below dot row is greater than highest row, we set falling into abyss to true, set, and we can go ahead and set resting to true, I guess, technically. And then we could just break. We could just break. Break's probably better. Break is probably better. Sorry. If it is resting though, we need to do is map dot put sand point Because it can't move. Put sand point and put 2. I think 2 is going to be sand. That's what's... No, it's not. That's not what this is running for. Oh, not resting. My bad. And we should be good. And so it's just asking how much sand has been put in there. I could count them up from our map, but I'm going to be a little bit quicker, and I'm going to do sand placed. I'm going to do this, and then we're just going to do a lap of sand placed here. Alright, let's see if this even runs. Nope. I was like, oh, I got an answer, I guess, but nope. Unfortunately. Alright, what do we get for the test input? 0. Oh. Hmm. 0, huh? Huh. Okay. So it should fall. So what should be happening is it should keep falling until it reaches row 8 or so. Oh, it just phases through. Wait, what? Did it just phase? Yes, we're at row 8. What? It should have 500. Oh, wait, this is back. No, that's right, that's right. Huh? What does this even give me? Six, 502. Yeah, 6. Okay, so it's there. They're there. 502. 6, 498. Yeah, so they're there. Point. I already have the hash and stuff on. Oh. Do I need a? It's the wrong one. Did I just forget to do a hash code on this? Objects.hashcode. Ah, okay, so apparently I forgot a hash code, and I think I should do an equals too. Not that equals is needed. There's that generate, isn't there? I don't know how yes, hash codes are done. Okay, there we go. All right, try this again. Okay, try this again. I forgot that. Why are you phasing through row 8? So we're on row 8, which is right here. Why do you not see anything below? Skip over that. Map. You should have 9. Oh, wait, you don't have 9,500. Oh, you just don't have 9,500. Oh. I messed this up. I need to do math dot. I'm always okay. I see. Math dot min. I see. Minimum of start column, end column, and max of start column, end column. That's why I messed up. Start row, end row, start row, end row. Let's try this now. There should be a few more things in there. Okay. 24 is the right answer. 625 is the right answer. All right. Hey, okay, so all right, only one mistake. You realize you misread the scan. This isn't an endless void at the bottom of the scan. There's a floor and you're standing on it. You don't have time to scan the floor. Assume the floor is infinite horizontal y equal to 2 plus the highest y coordinates. Example above. Okay, so there's a floor now. Okay, so we just have a floor now, so that's fine. So all this matters is we just need to sand place part 1, because what this is going to be is now we have the endless void. So we don't care about falling into the abyss anymore. So it's no longer falling into the abyss, it's now, well, I still want this falling into the abyss variable, because that ends part 1. But what I need is I need I'm just gonna say can fall. So while we can fall. And so falling to the abyss, which is this one here. So what I'm gonna do is I'm gonna change this to highest row plus 2. That's what it wants. And this is gonna set falling to the abyss to be true. But not break, because instead of breaking, well, it's a floor, and the floor is there, so it will continue instead of breaking. Or no, it'll place. If the below position if the below row is the floor, then it doesn't matter what it does, because it can't go anywhere. So we go ahead, continue, but we update this. So falling to the abyss is true. And this is going to be sand placed part 2 plus plus, I think. I don't know if... So 625 is what we want. Is this even gonna work? Uh-oh. Small example first. Infinite loop. Okay, we messed something up. So it's resting. We put in the map, increment those. We only want... I want to update that there. If the below row is not greater, we don't want greater than, we want equal to the highest row plus 2. That means the one below it is the floor. If it's the floor, then we said it's falling to the abyss because that will end part 1. We said it's resting because the one below is the floor. That means it can't go anywhere. So it is resting. Add it to the map. Add the current sand point to the map. Increment sand place part 2. And continue. Why is this going forever? I've done something wrong. It phases through. It phased through. Wait, what's my... Oh. Sorry, back to that. I didn't want to phase through. Okay, so we should get to 8. Good. Is it just a case of, I mean, really? Is it just really slow, or... Let's do this. Sand place part 1. Let's do this. Now we can monitor how many, because this should be 93. And it's way eclipsed 93. Okay, so I've messed up something wrong with part 2. So something with this is failing. Resting true. Row 10. I don't know what row 10 is. I didn't add a stop. I didn't add an endpoint. If sandpoint dot row equals 0 and sandpoint dot column. That's what I'm missing. I don't have an end for this. Hey, would you look at that? Did that not end? Oh, not continue, break. I could have set resting to true, but it's fine. Okay, back to our inputs. Please work. Really? No? Because I got 92. Was 92 the right answer? 93. Oh. Do this because it can't fall, but it hasn't been placed at that spot yet. And give me a minute and we'll submit it and it should be correct. But there we go. Hopefully I will submit. Hopefully I don't look like a fool right now and I'm assuming that my answer is going to be correct. But there we go. So it wasn't too bad. Today, half an hour. That's actually minus 2 mistakes. Minus the first mistake being, what was the first mistake that I forgot? I forgot to do the min max on these. That way it was correctly doing. So before it wasn't going backwards on my 6 more seconds. It wasn't going backwards. So if it gave me, I guess in this case, the example, if it gave me this, it wouldn't work because it was going from here, but trying to increment to here, to the 494. And that was my problem. All right, good. I don't look like a fool. But there we go. Not bad. And that should have been a little bit faster, but not too shabby. And overall, I was happy with how I solved that. So I don't think there's anything for me to really improve on the code here. It's, again, not the prettiest code in the world, but it works. And like I could maybe condense this down. I could condense these down a bit, but it's kind of whatever. This works. But yes, so today's problem is basically we are given, our inputs we're given is a bunch of coordinates, and these are coordinates that draw basically lines on a map. And so from these we can then draw a grid like this. You can see here, so 4984, that is from, was it here? Oh no, it's from here, and it says to go down to 49846. So we kind of draw a line here, fill these grid spots in, and then go over 4966, which is this. So that's how we get this little shape right here. So basically from these coordinates, we're given kind of paths that we kind of add into our world, add into our map, and place these solid objects, in this case rocks, but these solid objects in our world. And then what we're doing is it's saying we are placing sand at 500 right here. And it is placing the sand one at a time, and it is simulating where it'll rest at. So sand will naturally fall down as far as it can, and then when it can't fall down, it'll try and go diagonally down to the left, and then if it can't go diagonally down to the left, it'll go diagonally down to the right, and if it can't do that, it comes to a rest at that spot and just stops there. And only one sand piece is falling at a time, so you only have to simulate one bit of sand at a time, so one calculation at a time. So to do this, first step is to, of course, parse our input. We first parse out the arrows that were in the input here. This will give us our individual coordinates we need to go to. Of course, starting at the first one, which is 0, we will go from the start, which is the one below it, to the end position, which is the one after it. That's why we start at 1 here. I just mashed my keyboard for no reason. So that's why we start at 1, is because we don't, there's nowhere for the 0th index to go. And then because of that, then we parse out our coordinates. So we just split on the comma, grab the 2, and then grab the row and column from them. They go for column row is what they're designated as. That's column, comma, row, whatever. And then from there, we now just need to determine which direction we're going. Because we can't go diagonally, all we have to check is that if the start column does not equal the end column, we know we're going horizontally. Otherwise, we're going vertically. And the key here is what I messed up the first time is we need to make sure that we're always going from the lower value to the higher value. It doesn't matter if, in this case, for here, we're here. It doesn't matter if we go from here to here, if we go left to right or right to left, we're still filling in the same positions. We just need to make sure our logic handles it correctly. The easiest way is to always go from the lowest value to the highest value, because again, we're only going in one dimension, either horizontally or vertically. So it doesn't matter about which one we choose because it's going to get to the end. So making sure we do that, we can then fill our map in with all the points, and then also keeping track of the lowest kind of down, highest value row we visit, because that is our abyss. That's what we use for part 1. Getting into the actual simulation parts, we have two variables we're storing of how many sand is placed. Part 1 and part 2 are different. That's why I have two different variables. We have this value here for falling into the abyss. For when I originally wrote this for part 1, this is what controlled our main while loop, because we only want to run while we have no pieces falling into the abyss. Part 2, though, that changes because now there's a floor. There is no abyss. That's why there's the second one for can fall. This just controls the sand placed part 1 variable incrementing. Because if we are falling to the abyss, that would be end of part 1, so we stop incrementing this sand placed for future sand pieces that are being placed. Our logic here is, and for part 2, is while there is a piece falling, so while we can simulate sand going down, this runs. First thing to do is to start at 0, 500. Here's our sand piece, and then we simulate this piece as long as it's not resting. That just entails of getting the point below it, which is a plus on the row, by the way, plus on the row for below. And then for part 1, this is just below being less than highest row. But for part 2, because part 2 there's a floor at highest row plus 2, this can work the same. It doesn't matter for part 1 where you say the abyss is. It could be plus 2, plus 3, plus whatever, because it's going to keep falling down. That's why I just made it to be anything greater than the highest row, is there's no more platform for it to fall and sit on. But because of part 2, it makes it a floor there, we can just simplify logic and just do plus 2. If we do reach this point, we know we're at the floor, so we say we are falling to the abyss for part 1. That's what triggers our true here. Otherwise, we just say the piece is now resting, so it's hit the floor. It can't go left or right, it just has to be there. Add the sand point to our map, that way we know it's in the world. And then increment our sand place for part 2. This will then continue and continue this loop here, but because resting is true, it'll break out of this while loop and then go up and simulate the next piece. Go away Malwarebytes. If we have not reached the bottom of the map, we can simply now just check if the map contains the below point. If it doesn't, well, the sand piece just falls down. We set our sand point to be our new below coordinate and continue our loop, and it'll simulate again. If it does contain a below point, now we need to check the below left coordinate, which is again just this logic. Do the exact same thing, check if this coordinate exists in our map. If it doesn't, add it in, or if it doesn't contain it, update our sands point to be the below left coordinate and then now simulate it from that spot. If it does contain it, we go now to the bottom right, same thing. If it doesn't contain it, move it to that location, simulate from that position, and keep going. If it makes it through all those positions, so it can't go down left, can't go down right, now we just need to check if it is at the initial spot. If it's at 0, 500, that means it can't move from its initial spot. That means now we know we are at the end. The piece cannot fall. We increment our sand place because we are still placing it at 0, 500, but we can't place any future ones. And then we break out of this loop, and that's what ends this whole thing once and for all. But if it isn't at 0, 500, that means we need to place the sand in the world, which is just setting the resting to true. That means this piece has come to rest. Adding to our map so that way future sand pieces respect that there is one here. And then if it's not falling to the abyss, we increment our part 1. If it is falling to the abyss, well, either way, we increment our part 2 because part 2 is always being calculated. Then once and for all, once again, in this case, we have either at 0, 500, this loop will end, everything will end, we'll get our 2 answers, and that is it. That was probably a little more in depth than it should have been, but this kind of just worked out to read it almost line by line. But at any rate, that is all for day 14. Hope you guys enjoyed. I'll see you guys tomorrow for day 15. Peace out.